Hi, Dan.
How's everyone doing today?
Good.
Good to hear it.
Pretty good.
I'm going to drop the link in the chat right away here for the link to the Git for today's week. So if you want to kind of check it out sooner than when I do it, I know I go kind of through these pretty fast. And if you want to get it checked out so you can follow along a little sooner in the meeting, that'll make it a little easier for you. These are always in the same place too, so you can easily find them yourself. They're named by the date, as I'm sure you've all noticed. And make sure I'm sharing my screen first this time so that we don't run into that sort of issue again. You guys can always interrupt me if I make that mistake again. I appreciate the shout out from Tushar last week for pointing that out to me. Okay, with that, let's get started. Okay, so today is my third lesson on the solid principles. Today we're talking about the L in solid, which stands for the Liskov substitution principle. Once again, just a quick recap. The solid principles were coined by Robert Martin, famously known as Uncle Bob, who's written many books on clean coding. And they were originally created in the year 2000, and we're mainly following these principles because they add maintainability, reusability, and testability to our projects. So with that, let's dive into the L. So the Liskov substitution principle was first defined by computer scientist Barbara Liskov in 1986. And she wrote in her original paper, let phi of x be a property provable about objects x of type t, then phi of y should be true for objects y of type s, where s is a subtype of t. All right, I'm quite certain not a single one of you really kind of followed that, but that's how it was actually originally defined. But what that actually means is that an object of a particular type should be replaceable by an object of a subtype without breaking the application. So in much simpler terms, that's all we're trying to do here is make sure that when you replace an object with a descendant object, that you don't break the application in the process. I will take a small side note here to note that Barbara Liskov was a woman, and it's kind of interesting in computer science today, we do see a lot of men in this field. It is statistically 92% male-dominated field, but back in the early days of computer science, that wasn't the case. In the early days of computer science, a lot of computer science was done by the women. And I think it's really useful to point that out, especially if you've got spouses or kids or daughters or sisters or whoever who are really interested in computer science, but they look at the sort of statistics and think, well, you know, maybe computer science isn't for women. No, that's bullshit. You know, back in the early days, women did all the computer science and the men didn't. And later when it kind of became classified as a STEM field, and for some silly reason, people seem to think STEM was a gender specific field. It's not. But just so you know, a lot of these great computer science principles that we're basing this on were brought to us by great women. So when you look back in the history of computer science, you look at, you know, the women who, you know, made the software to go to the moon. There's a lot of great computer scientists who a lot of the technology that we base today on were women. So if you ever hear anyone kind of like along that line of thinking that women can't do this job, it's like, no, yes, you know, we've got the history to prove it. So anyhow, enough of my little soapbox. What does the Liskov substitution principle actually mean? So in general, it means that a child object that can't perform the same actions as its parent object causes bugs that usually won't be discovered until runtime. So this is the sort of reason why we don't want to violate the Liskov substitution principle. It's not so much because it causes bugs, because we already know that. It causes bugs that are hard to find. It causes bugs that you only find through QA testing. A lot of the sort of things that we do with the solid principles also have the side benefit of being bugs that are detected at compile time rather than detected at runtime. The bugs that don't show up till runtime are the ones that are the hardest to track down and the hardest to fix. So in general, these are the sort of principles you need to follow to make sure you're following the Liskov substitution principle. Child object should be able to do everything its parent can do. Doesn't have to do it in the same way, but it does need to do everything its parent to do. It should respond to the same requests with a valid response. Child object's method should accept any input that the parent method accepts. It can accept more input than the parent method accepts, but it shouldn't accept anything less than what the parent accepts. And it should never return a value that the parent object would never return. It can return a subset of the values that the parent object would return, but it should never return something the parent object would never return. And this is called code contracts, and I'll talk more about code contracts in another lesson. But it is important to understand that both the input contracts and the output contracts of any method, a child object's implementation of that method should not violate those contracts. And if a child can't fully implement its parent's functionality, it should probably be deriving from a different parent. Now, we'll take a minute to note, sometimes you can't control what the parent object is. So sometimes you are deriving off of a class that's part of the framework, or you're deriving off a class that was written by somebody else, and you can't do anything about that. You can't change the abstractions in the parent class. And that is where a couple of these exceptions that I'm going to talk about in the next slide, about the not supported exception, not implemented exception, that's where they come in. And technically, that is a violation of the Liskov substitution principle. But in general, whenever possible, you don't want to violate this principle if you can avoid it. What does code that doesn't follow Liskov substitution smell like? So if you have to override a method, but the method can't do that in your child class, the typical way of handling that is to throw either a not supported exception or not implemented exception. You would throw not supported in the scenario of it's not possible for the child to do that. You'd throw not implemented in the scenario of you didn't write the code to do that, but somebody could. But in both cases, if you're throwing either of those, there's a really good chance you're violating Liskov substitution principle. If you're hiding a virtual parent method in a child class with the new keyword, so I don't know if you've used the new keyword in this way before. Probably most of you haven't. And frankly, you probably never should. But there is a way of introducing a method in a child class that is a replacement for the parent method that is not an override of the parent method. And that's where the new keyword comes in. Generally speaking, you shouldn't be using the new keyword in that way. There are legitimate scenarios for them, but they are few and far between. And as I mentioned before, violating the code contract of a particular method is the kind of other way you violate the Liskov substitution principle. So either not implementing the method or implementing it in a way that is more restrictive than the parent, that is also a violation of the Liskov substitution. So if you are throwing an argument exception for, or any other exception for that matter, for input that the base method wouldn't throw an exception for, it's called with the same arguments. That's a violation of Liskov substitution. And if you're returning a value that is has stricter type restrictions than the parent method would return, that's another example. So you're less likely to trip over that one. But a good example of this is if you're returning a mutable collection, a read-only collection as an I collection, because that's what the parent method signature is. A I collection is assumed to be mutable, and you will get an exception if you try and treat it as mutable when it isn't. So if you're ever returning a read-only collection, it should only return that in the signature. And if you are deriving from a parent class that returns the I collection, you should also be returning a mutable collection. Okay, so a couple things to keep in mind. So usually fixing the Liskov substitution principle means that the parent class and the child class should actually be sibling classes of each other, deriving from a different abstraction parent. So sometimes that abstraction already exists. Most of the time it doesn't, and you need to refactor to add it, which is what we'll be doing in today's workshop. And this is kind of the other thing I'll mention, is like when you talk about the Liskov substitution principle, a lot of times developers make this mistake because the thing that they are making a model of in the computer world is a subset of a larger grouping. And so the class representing that larger grouping and the class representing that subset, you naturally kind of assume that, it should be a member of the larger class. But that's not always the case. So the canonical example given by Uncle Bob is to talk about squares and rectangles. So we all know, because we all took high school geography. Anyway, sorry. We all took high school math, and we all know that every square is a rectangle. So you might think it makes sense to have, if you had a class representing a rectangle, to have a class representing a square that is a child of a class representing a rectangle. But that's actually a violation of Liskov substitution if you were to do that. So a class representing a rectangle might have properties like length and width. And if you set the length, it doesn't change the width and vice versa. But a square is only a square if the length and the width are the same thing. And so if you made a class that represented a square and you derived it off of the class representing a rectangle, then your properties for length and width would have to both change each other. And that would be a violation of the Liskov substitution principle because we're having an unexpected side effect when we're changing the child property. So just because something is a child of something else in the real world doesn't necessarily mean your virtual abstraction or your class representing that something in the real world will be a child of that in your code. All right, so that's the theory for today. Let's jump into our little hands-on exercise. All right. So for those of you following along, I am once again basing my examples on a fictional application I've written here to track somebody's address book. And if I was listening to my product owner in my previous example, oops, sorry. Where'd that go? Yep. If you're following along with my previous example, sorry. Assuming this scenario has occurred, that my product owner has talked about this address book app and they've come up with this great idea that now we don't just want to track somebody's name, email, and phone number, but it would be nice if we could also keep track of their birth date. So we added this feature to keep track of their birth dates, and it got merged into production, yada, yada. So we now have this great little feature where if I've got somebody's name, I can now see what their date of birth is. And we even got smart and fancy. And if it's close to their birthday, we show this nice little birthday cake icon. And we also have a button where we can click and it'll send them a birthday card so that, you know, you can look at your address book and see, oh, hey, it's Lisa's birthday. Let's send her a card. So today I'm trying to address the problem of what do we do if we want to put something in here that is not a person, but a company. And so I want to add a company. In this case, I'm going to add Moe's Tavern to my address book. Well, Moe's Tavern isn't a person, so it doesn't have a first name, it doesn't have a last name, and it definitely doesn't have a date of birth. But there is a lot of logic here that we'd like to carry over. So we do want to keep, you know, our ability to click a button to call a person or email a person, but the ability to send a card kind of doesn't make sense because this person, it's a company, it doesn't have an email address. So in order to reuse that logic, I thought I was getting smart here, and I took my contact class, which now has my birth date logic. And the first thing I did is I put this virtual method on here that takes the first name and last name, puts them together, and calls it name. And I thought, oh, wow, this will be brilliant. And then I derived a class called company off of that, and it has a property for the company name. And then instead of taking the first name and last name, I overrode that method. And I also overrode the date of birth and it's near their birthday and all this stuff because this doesn't apply to companies. And so now let's look at how my app behaves when I'm looking at Moe's Tavern. So while this looks right here, if I click the send a card button, well, it gives me an exception because, of course, corporations don't have a birthday, so that doesn't make sense. And if I click the edit button here, well, I'm still seeing a first name and last name, even though this is a company. All right, so I've got the wrong abstraction here. We need to fix this. So first of all, we've got a class called contact, and right now it doesn't represent a contact, it represents a person. So we want to split this out into a generic abstract class that represents all contacts and have two children of that, one representing a person and one representing a company. So I'm going to start by doing a refactoring. I'm going to extract a superclass from this. And it's going to give it the default name of contact base. We're going to change that later. And we're going to pick the properties of this that apply to every contact, regardless of its type. So the ID, the contact type, name, first and last name doesn't apply. Name does, but we'll make that abstract for the moment. Date of birth doesn't. Email and phone does. Birthday doesn't. Email and phone link again. Birthday doesn't. Okay, so now we've got identified what parts of this belong to our common shared abstraction and what parts don't. So we're going to run that refactoring, and now it's split this out for me. So now I've got contact base, which applies to everything, and I've got this contact down here, which really just applies to people. So these names, contact and contact base, kind of aren't that great, so let's turn those around. So let's make this a person, and let's change contact base to just be contact. As the nice side effect of now my company class, which still derives off of contact, doesn't have those person-related fields in there, so we can take those out. Now we simplified this abstraction because we're not overriding anything. So by itself, those two changes, that's all we needed to do to fix Liskov substitution principle, but we've also introduced some issues with the open-close principle, which I talked about last week. So we're going to need to fix those. So we move this to its own file. Done. And now we're going to need to figure out all those places where Liskov substitution was broken. So one of the nice things about using a strongly typed language is most of those things will just show up at build time. So let's run a build and see what breaks. So, all right, well, we've got some breaks in my database Cedar class. And most of those are just because I'm trying to add a person as a contact. So let's change that to person. That. I also need to go into my database context class, and right now it's determining what type of object to return based on what the contact type is, and it's returning a contact for a person. We don't want it to do that anymore. We want it to return a person object for a person, so we'll fix that. All right, so that should fix all of the sort of issues that we have with the model itself. So now let's see what happens. Oh, more things are still broken. Let's take a look at what's broken now. So over here, we have a send birthday card, and it's running into an issue because now it's getting a contact, and we don't know if the contact is a person or not. So we know this method only actually applies in the case of a person, so let's put in a check for that. I'm going to show you a couple things first. If you've worked with older versions of C#, this is how you would normally implement this method. And you do something like this. Not a person, we're going to return bad request. All right. And if you worked with C# prior to version 5, that's how you'd write this code. Thankfully, in newer versions of C#, we can actually optimize this further. So this typecast that always happens after this is, there's actually a nice convenient shortcut for making that happen, which looks like that. And since we want to reduce the amount of indenting, and we've got an immediate return there, if we flip this around, we can actually return this like so, and then we can take this else out, redundant else. And now we've got some much simpler, cleaner code, so much so that I can even take out those brackets. So first thing I wrote was how you do it in like C#5. This is how you can do it now in C#, I believe 8 is when they introduced the is not syntax, but certainly kind of convenient for that. All right, now more things are going to break when I try and run this, but let's try and run it and see what breaks next. All righty, so let's take a look at what's broken now. Okay, so good. Looks like we've fixed all the places in the C# code. Now we just need to fix places in our Razor templates. All right, so let's look at that first page. So this first Razor template handles that initial page where we're listing all the date of birth. All the contacts in one table. So, and it's complaining now because date of birth isn't necessarily a property of contact. So all this particular display name method does is come up with the name for that field, which is already defined in the person. So I'll show you that for a second here. All it's trying to do is come up with this property here. So in this particular case, we can tell it always take the property from that, even if it's not a person, because this is the header and not the actual table. So we're just going to do a quick typecast here. I could have just as easily typed in the words date of birth here and solved the problem that way. Down here, we've got a situation where it's going to show a birthday, but again, item may or may not be a person. So we're going to need to put something in here. I'm going to implement this with an if statement. If you were paying attention to my lesson from last week on the open-close principle, you may remember that an if statement based on a concrete type is a good chance you're violating open-close. And this will be an issue here in terms of violation of open-close, because if I'm adding new descendants, I may or may not have to revisit this method. I will be talking more about this next week when I talk about the interface segregation principle on a better way of handling this exact problem. But for now, I'm just going to do a quick check to make sure if this is a person and only display the date of birth if it is. So this item is person, and we're just going to plunk this logic. And again, I can use the cast set and fix that there. So now a couple other things. We don't want to actually show this part here, so why don't we put that in a little if block for a person. In this case, I don't actually need to do the typecast, so I'm not going to. And if you're really eagle-eyed, you'll notice that these characters here are going to repeat in a certain circumstance, so we'll just put those over here instead. Take them out of here. All right, so with that, we've fixed up that first page to handle this. So now we've got a few other pages here. So we've got our create and our edit pages, and both of those create and edit pages prompt for first name and last name. And you'll remember when I did the quick demo, we had this issue before of if it was a company, it was prompting for first name and last name still, even though it was a company. So you could model this with an if block, but again, a violation of open-close principle. It would actually make a whole lot more sense to make a specific view just for the fields that are specific to a person and not a company. So that's what I'm going to do. I'm going to start with my existing create. I'm going to make a duplicate of it, and I'm going to make a partial view from that. I'm going to call it person. Call something called convention over configuration here when I do this. So I've just duplicated that, and I'm only going to keep in here the parts that are specific to person. That's the first name, that's the last name. Take all that out, that up, and because this is only going to be used on a person, we can change the model type to person, which makes it identify those things correctly. And since we don't actually have it, we need to put date of birth in here as well. Birth. Now I have a partial view that works for people. I also want to make a partial view for companies, which only has the field specific for companies. Company. And in the case of companies, the only thing that's specific to a company is the company name. Name. Guys out. Done. Okay, so now I've got a partial view for person, which only has the field specific to a person, and a partial view for company, which only has the field specific to company. So I want to use that partial view in my create, and I'm going to take this out here, and I'm going to instead tell it to replace it with the partial view I just used. Made. Alrighty, and I'm going to tell it to always use based on the character there. So now it's going to look up what the contact type is of the contact, and it's going to put in the appropriate partial view. And this is where I get it back to where I mentioned about convention over configuration. Because I've specifically used contact type here, it's going to look for a view that matches the same name And in doing this, I'm actually encouraging open-close principle in that I can now add additional contact types just by adding another subclass and adding another view, and I never actually need to come back to this class and modify it further. All right, so we have this same problem in both my create views and my edit views. So I'm going to go into my edit view and fix the same problem here in the exact same way. And with that, I think we should be good to go. So let's give this a try. All right, so now on my contacts page, I've got Mo's Tavern here, but it's not showing a date of birth, and it's not showing me my send card. And when I hit my edit button, now I've got an option to edit the company name, and I don't see first name, last name, or date of birth. But when I go back to the other classes, I can see first name, last name, and I've got the option of putting in date of birth as well. Alrighty, so there's one other thing I do need to fix, and that's up here. I've got this create new button, and when I hit create new, it's going to throw an exception because it doesn't know what type of contact it should be creating. So that's easy enough to fix. Let's go back to our index page. Up here, instead of having a single action for create new, we're going to create an action for each type. So we're going to do that with a quick for each loop. Instead of saying create new, we're going to create new. Okay. And we're going to pass that into our create action as a parameter. It's going to be called, unsurprisingly, contact type. So in my controller, I'm going to get that contact type that I can now use to decide what type of contact we're creating. All right. So again, this is another one of those places where if you were using an older version of C#, this is how you would write it. And if you're using a newer version of C#, there's actually some convenient syntaxes to make this shorter. So we're going to take advantage of those right now. And let's give this a shot. Make sure it all works right. Okay, so now I've got two links here, one for creating a new person, which indeed gives me a new person, and one for creating a new company, which indeed gives me a new company. All right, with that, that is the end of today's lesson. Questions, comments, hit me up. You guys are always such a talkative bunch. All right, if there are no comments or questions, once again, I'm going to drop a link in the chat. I'm going to encourage everyone to just take 2 minutes to fill it out with your feedback on today's lesson. Please take just 2 minutes to do it. It really helps me kind of identify if I'm on the right track with these lessons or not. Appreciate the feedback very much. If you have any other comments, questions, or concerns, please feel free to hit me up in the channel specifically for the software craftsmanship workshops, and I'll be more than happy to answer your questions, or you can hit me up directly on Teams and I will talk to you there as well. All right. Thank you for your time, everyone, today. Join me next week when we talk about the I in Solid, which is the interface segregation principle, and we'll be using it to address some of those minor concerns we had with the violations of the open-close principle that we saw today.
Thank you.
Thank you.
Thank you, everyone, for your time. See you next week.
Thanks.
Same time,
Thank you.
same channel.
Thank you.